Hi guys, Mr. Robeson here, AP Calculus. Today is the day we are going over the last set of derivative rules, the inverse trig function derivatives. All right, the rest of this section, the rest of the Unit 4 will be going over applications of derivatives, but this is it for rules. So no more things to memorize after today. All right, so here are, I'm just giving them to you. Here are the rules for the inverse trig functions. All right, so there are 6 inverse trig functions, so there are 6 rules. The ones you really need to know are these 3. And the reason I say that is because the ones for these C trig functions are exactly the same as these 3, but with negative signs. All right. So I've heard the AP exam generally just sticks with these 3 over here as well. All right, so the derivative of arcsin is, well, everything's a chain rule. So it's the derivative of the inside divided by the square root of 1 minus the inside squared. Tangent is the derivative of the inside over 1 plus the inside squared. Arcsecant of something is derivative of the inside over the absolute value of the inside times the square root of the inside squared minus 1. All right, you might be wondering where all these things come from and why they all have like u squared and like 1s in them. Well, it has to do with the Pythagorean theorem, and we'll go ahead and derive the formula for arcsine of x. So if we had x here, this would be x, this would be 1, this would be x right here. All right, so we're going to derive that formula. So we're going to start off by saying y equals the arcsine of x. All right, and now we're going to get it into a form where we can take derivative, and that would be if we took the sine of both sides to cancel out the arcsine. So then that would give us that the sine of y equals x. But now the way to differentiate this would be implicitly. So we would take the derivative of sine, which would be cosine of y, times derivative of the inside, y prime, equals derivative of x, which is 1. And now to solve for y, we would just divide both sides by cosine, and we get y prime equals 1 over cosine of y. But we need to get back to x's, right? We want our answer in terms of just x's, because our original function was just in terms of x's. So we go back to this line here, and we draw the triangle. All right, so we did this at the end of the section before on 4.2a. And let's see, this would be our angle, y. Sine would be opposite over hypotenuse. So we just make this x over 1. So now to get this side, we'd use the Pythagorean theorem. We'd say x squared plus that missing side squared equals 1 squared. So x squared plus a squared equals 1. We're trying to solve for a, so we would subtract the x squared. That's why we have this minus x squared here, or minus u squared on the bottom. So a squared equals 1 minus x squared. And then we take the square root to solve for a. So that means this side is the square root of 1 minus x squared. Which means the cosine of this, cosine of y, would be the adjacent square root of 1 minus x squared over the hypotenuse, over 1. Which is just square root of 1 minus x squared. So this would be 1 over the square root of 1 minus x squared. And that would be the derivative of y. Right? But we said y is arcsine of x. So that means the derivative of arcsine of x is just 1 over the square root of 1 minus x squared. And if we had something inside here, say like a u or some sort of function of x, like we'd be doing a chain rule. So it'd be times derivative of the inside, and whatever was inside would be, the whole thing would be here squared. All right, so that is how we come up with these rules. We could do the same thing for arctan or arcsecant or all the rest of them over here. And it works out the exact same way. All right, so some examples. So we've got arcsine here is our inside. This would be our u. All right, so the derivative of that is, well, it's the derivative of u, like the derivative of the inside, 3 over the square root of 1 minus this whole thing squared. 3x quantity squared. You can leave it like that if you want. Technically, it's a little prettier if we simplify and say this is 1 minus 9x squared. But again, this is perfectly fine. All right, over to here. Again, working on arcsine, we've got the square root of x, or x to the 1/2 if we want. So its derivative will be, well, derivative of x to the 1/2 is 1/2 x to the negative 1/2 over the square root of 1 minus the square root of x quantity squared. All right, well, the 2 from the 1/2 can move down. This x to the negative 1/2 could also move down, where we'd say it's 1 over the square root of x, and the square root of x part would move down. So we'd get 1 on top. We'd get 2 square root of x times the square root of 1 minus x, right? Because we had the square root of x squared. We can leave it like that, or we can distribute the square root of x part if we want. 2 over, we'd have x minus x squared like that. We can just distribute this in here. All right, so we can write it like this, we can write it like this, you can write it like this. Any way is fine, really. All right, next up, we've got a 4 out front. Well, that just means it's 4 times the derivative. Simple as that. Derivative of x over 2 is 1/2. Tangent was 1 plus this guy squared. All right, tangent's the one that doesn't have the square root for whatever reason. So 4 times the 1/2 goes on top. That's just going to be 2 up there. So it's 2 over 1 plus x squared over 4. Now, we can leave it like that, or we can get common denominator down here and flip and multiply and do all sorts of fun stuff. Usually, yeah, that's what we end up doing. So if we do that, we'd say this is 2 over, say 4 over 4 plus x squared over 4 would be 4 plus x squared all over 4. And then we'd flip and multiply. In other words, the 4 is going to come up here. 4 times 2 is 8 over 4 plus x squared. Any of these forms are fine, guys. This is your final, probably the nicest looking form. So if it was on multiple choice, chances are it would probably look like that. But again, this is perfectly fine as well. All right, arcsecant of e to the 2x. All right, so let's see. We got to remember the formula for arcsecant. So it's on top, it's the derivative, which is e to the 2x times derivative of 2x, which is 2. So 2e to the 2x. All right, in front, we've got the absolute value of u. So the absolute value of e to the 2x, which isn't necessarily necessary to put the absolute value signs because e is always positive anyway. And then it's the square root of, well, let's see, sine was 1 minus u squared. So this guy's got to be the other way around. So it's got to be this thing squared, e to the 2x squared minus 1, because it's not the same thing as sine. It's backwards. All right, so we can square this. That's going to be e to the 4x. So this, we don't need the absolute value anymore. And then we can cancel out this e to the 2x with this e to the 2x. So we get 2 over the square root of e to the 4x minus 1. Remember when we raise something with an exponent to an exponent, we multiply those exponents. So 2 times 2 gives us 4x. And there's our answer right there. All right, you guys can go ahead and try this one. Take a minute and pause it. All right, so arcsine says on top is the derivative of this guy. So that's 2x. And then we've got the square root of 1 minus this thing squared. So it's going to be 2x over square root of 1 minus x to the 4th. And that should be our answer. And that looks like answer choice C. And yep, there it is, answer choice C. All right, let's throw a natural log in there. Sure, why not? All right, so tangent says, let's see, the derivative is, well, it's the derivative of the inside, which is 1 over x, times 1 plus the inside squared. Like that. If you look, I don't see that anywhere as an answer. There's no 1 over x on top. Looks like there's some 1's on top, so maybe the x just moved down to the bottom with these guys. So if we bring the x down to the bottom, it'd be 1 over 1 times x, x times the ln of x squared, like that. And hey, look, there it is. That's answer choice D. So there's our boy there, answer choice D. All right, these can get more complicated, especially when we want to simplify afterwards. So here's one, we want to take the derivative of this. So y prime equals derivative of arcsine. Well, it's just 1 over square root of 1 minus x squared plus this guy. Well, that looks like it's going to have to be a product rule. And I would probably want to rewrite this as 1 minus x squared to the 1/2 times x. So it's first times derivative of the second, 1/2, 1 minus, oops, I lost a squared in there, 1 minus x squared to the 1/2, or sorry, to the negative 1/2, because we subtracted 1, times derivative of the inside, plus the second, times derivative of the first, which is just 1. All right, we can clean up this guy a little bit. The 1/2 and the 2 here are going to cancel. We've got x and a minus sign. So we're going to have a negative x squared there on top. And we're going to have the square root of 1 minus x squared on the bottom, plus the square root of 1 minus x squared. We can take these two fractions and put them together. We might even be able to do all three, but let's just put these two together first and see what happens. So they already have a common denominator. That's why I wanted to just put these two together first. Plus, not equals. It does equal, actually. But for now, plus. All right, well, wait, these guys are both the same. Up here, it's to the first power. Down here, it's the square root, so it's to the 1/2 power. So if we just subtract, we're going to get, subtract the exponents, we get, or divide, we're getting the square root of 1 minus x squared plus the square root of 1 minus x squared. Well, if we're adding them together, that means we just took two of them. Huh, well, that one simplified a lot. That's not normal, guys. Don't expect that to happen every time. All right, one more example. So we're back to implicit differentiation. We want to find the value of dy dx at the point 1 pi. So x is 1, y is pi. When y equals the arctan of y quantity squared minus x times sine of y plus pi. All right, well, we want to take the derivative implicitly. So anytime we take derivative of y, we're going to put a dy dx. Here we bring down the 2. We leave the inside the same. Arctan of y to the 1 less exponent times the derivative of the inside. Derivative of the inside is derivative of arctan. So we'd have derivative of y is dy dx over 1 plus y squared minus, and now we're doing this guy. So we got to do a product rule here. You could just put the negative with the x, but I already wrote the minus out front. So it's first times derivative of sine of y, which is cosine of y, times dy dx, plus the second times derivative of the first, there we go, plus derivative of pi, which is 0. Pi is a constant. All right, so now we want to find dy dx when x is 1 and y is pi. Let's just plug in. All right, we might not be able to completely solve for this. So we get 2 arctan of pi. Was that point switched? Did I have that point backwards? I don't know. Dy dx over 1 plus pi squared minus, let's see, we've got 1 times cosine of pi, that'll work out easily, times dy dx plus sine of pi, which is 0. Cosine of pi is -1. So these two negatives are going to cancel out. So we're going to get dy dx equals 2 arctan of pi. I don't know whose angle's tangent is pi. I'm going to put the 1 plus pi squared with that and just put the dy dx next to it. Over here we've got plus a dy dx. All right, so we want everything with dy dx on one side, everything else on the other side, so we could subtract this over. So if we subtract this guy over here, we're left with 0 over here equals 2 arctan of pi over 1 plus pi squared dy dx plus a dy dx minus a dy dx. So those two are going to cancel each other out. All right. And now if we divide both sides by this guy here, 2 arctan pi divided by 1 plus pi squared, 0 divided by a number is going to be 0. So we get that our derivative dy dx is 0 here. That was an odd one, but you know what? Whatever. It was good practice. Good practice with taking arctan derivative and implicit differentiation. Remembering that is a thing. We still have to know how to do it. All right. So now we've gone over all of the derivative rules. Here they all are on one place. You want to take a screenshot of this and keep it with you, that's fine. Keep it on your phone so you can just refer back to it. So all the derivative rules right here in one page. All right, the arc trig ones are at the bottom. We got the regular trig ones up above it. So we got arc trig here. We got regular trig here. We've got the exponential ones here and the ln over here. Absolute value, we kind of skipped that one, but we usually break up absolute value into two separate functions. Like usually we do absolute value of x equals, x if x is greater than 0, and negative x if x is less than 0, like that. And then we just take the derivative of each part and we lose the equal to, right? We don't have the equal to because it's not defined at a corner. All right, and we've got all the other derivative. Here's the product rule, here's the power rule, derivative of a constant, quotient rule, times a constant, and adding or subtracting. All derivative rules all in one place. Very convenient. All right, so that is it for inverse trig. Check out the homework for 4.2. We'll go over it together in class. Make sure to ask questions if you have questions, and I will see you next time.